Okay, today's lesson is 4.6a, inverse trig functions. So before we get too deep into it, I want to remind you what inverse functions are or how we find them. And how do we find inverse functions is we switch the x and the y. We switch the domain and the range, and that's how we undo functions in math. So what characteristic must a particular function have for the inverse to be a function also? Well, it has to be a one-to-one function. How do you know if it's one-to-one? That's when it passes the horizontal line test. So if you think about our sine, cosine, and tangent functions, do they have this characteristic? Are they one-to-one functions? And clearly they are not. So here is a little snippet of the sine function, cosine function, and the tangent function. Okay, and what we're doing is we're trying to create a one-to-one function that has all of the range values. So the range will stay the same, but I have to restrict the domain, because if I don't restrict the domain, it's not one-to-one. So we're picking a piece, cutting off a piece of each of these functions so that we get every possible domain value and every possible range value, because they both repeat as they go on. So we're picking that piece closest to the origin. And so if you look at this one here, I've highlighted the points, the key points there, but basically you can see that my y values go between -1 and 1, and the x values that are going between those points are from there to there. So that is from -π/2 to +π/2. Okay, and that is that piece of the graph that we need. Onto the cosine function, we're not going to use that piece from -π/2 to π/2, because then we don't get all possible values. So this one, we're going to choose this piece of the graph, and that is between 0 and pi. You can look at it on those points. And on the tangent function, we're taking just this middle piece in between those two asymptotes, and those two asymptotes occur at -π/2 and π/2. Now, why is that so important? Because you actually have to remember these values. Okay, as I just set up here, how do you find inverse functions? We switch the x and the y. This lesson is about inverse trig functions. So if this is the original function, then the inverse we're going to get by switching. So my domain is now my range is now my domain for each of these functions. Okay, and you've seen these graphs before because we had them on a previous lesson. But more importantly, you have to remember these ranges. Okay, sorry. Stop. Pause for a second. Wow, I got bombarded there, so I had to turn off the notifications. Anyway, you have to remember these range values. So what I think is an easy way to remember it is to have a little visual aid. So I think of the unit circle, okay? And on your unit circle, okay, the cosine values go between 0 and pi. So that is these two quadrants. So every inverse cosine answer has to be between 0 and pi, so it's between these two quadrants. Every sine and tangent value is between these two quadrants. So that's why I write it right there. And one of the things that I also write is -π/2 or -90 degrees, because my answer has to be written that way. It's in the fourth quadrant, but you have to write it as a negative angle, not as a positive angle. And if you want more explanation of that, please see me. I'll be happy to give you further explanation of it. Okay, so what you're going to do, got to pause one more second. So what we are doing when you see these problems that say arc sine or inverse sine, okay, you want to think to yourself, what angle has a sine of this value? Okay, easiest way to do it, because it's a very helpful tool and helps you get familiar with it, is to use your unit circle. So if I'm looking for the angle whose sine is the square root of 3/2, then I'm going to pull up my unit circle. And with sine, y'all, you only have to look in this quadrant. So remember, the sine is the second coordinate. Well, where is the second coordinate square root of 3/2? It's right here. So my answer is going to be pi/3. So I'm going to come back here, and my answer to the arc sine of square root of 3/2 is pi/3. So the next one says inverse sine of -2 pi. Okay, back to my unit circle. Where is the sign negative 2 pi? Well, it's not. I'm telling you all, you only have to look here for the sign. I'm going to explain a little bit further in just a second. But more importantly, you didn't ever see it. So the answer to this particular problem is that it does not exist. That's what D and E stands for. Now, if you take negative 2 pi and you put it as a decimal, that's negative 6.28. Okay, remember up here, it always has to be between negative 1 and 1, and negative 6.28 is not in between those two numbers. So that's why there's no possible answer. Okay, the last one for the sine. What is the arc sine? Excuse me, what's the arc sine of negative 1? Or what angle has a sine of negative 1? Okay, now this is different, and this is something that is special to the sine and the tangent function. Remember, they're in these quadrants, and you have to write it like this. So whenever you have a negative with the sine or cosine, the first thing you want to do is just pull the negative down and put it in your answer, and then ignore it in the problem and say, okay, where's the sine 1? So I go back to my unit circle. Where's the sine 1? The sine is 1 right here at pi over 2. So my answer is going to be pi over 2, and it's negative pi over 2. That's the answer to the problem. Okay, and that will help you always. If you can remember that, just carry the negative down and treat it like it's positive. You won't ever mess up, because some of y'all are going to want to say it's 3 pi over 2, but that's not in our range. Okay, so here are some cosine examples. And you are, just like we did before, what angle has a cosine of negative square root of 3 over 2? And the nice thing about cosine is you don't have to worry about any of that fancy stuff. You just look in the first two quadrants, and we're looking for negative square root of 3 over 2. Well, cosine's negative over here, and here is the negative square root of 3 over 2. So the inverse cosine of the negative square root of 3 over 2 is going to be 5 pi over 6. All right, next problem says arc cosine of 2.5. Okay, just like we have with sine, 2.5 is larger than 1. Cosine can't be larger than 1, so there is no angle that exists whose cosine is 2.5. All right, last one, in of the cosine. Inverse cosine negative 1/2. Okay, go into my unit circle. Looking in the second quadrant, where is the cosine? First one, negative 1/2. So my answer is going to be 2 pi over 3. And that's all you have. So cosine's pretty easy. You don't have to worry about any special tricks. But tangent you do, just like the sine. Okay, we're doing again. What angle has a tangent of negative square root of 3 over 3? Well, I have a negative in there. So if I have a negative in there, I'm going to carry that negative down. And then I'm going to go look for the positive square root of 3 over 3. And on a unit circle, y'all, when you're looking for tangent, as it says here, tangent is sine over cosine. So you're taking the y-coordinate and putting it over the x-coordinate. And when you're dealing with these, y'all, because they all have a 2 on the bottom, you only have to worry about the top. So if I put 1 over the square root of 3, does that give me the square root of 3 over 3? And I think y'all know it does. So my answer is going to be pi over 6. I carried my negative down, so it's going to be negative pi over 6. Our last problem, inverse tangent of negative 1. Again, I got a negative. I'm going to carry it down. Where is the tangent 1? On my unit circle, 0 over 1 is not 1. I'm looking for where the numbers are the same. And they are the same right here. Square root of 2 over the square root of 2 is 1. So my answer is going to be pi over 4. So it's going to be negative pi over 4. And that is all you have for inverse trig functions on our unit circle. So if you have any questions, please don't hesitate to contact us or come see us. Thank you so much, and y'all have a great day.